we're actively collaborating with our suppliers to innovate and bring these new products to market utilizing these new fluoropolymers. So it's common for fluoropolymers to be produced through emulsion polymerization. These processes typically have used fluoro-surfactants as an important processing aid. Fluoropolymer producers have taken different approaches at their next generation products. So some are focusing on advancements in control and abatement of fluorosurfactants in the emission streams, making sure they don't enter the environment, while some others are working to eliminate fluorosurfactants altogether in their polymerization. So if there's no fluorosurfactant used in the process, we consider this an NFS polymer, a non-fluorosurfactant polymer. And I'll mention that the definition of NFS varies some from supplier to supplier. So there may be some nuance when you hear the term, but when I'm referring to NFS, these are polymers that use a non-fluorinated surfactant or no surfactant at all in their polymerization, okay? So our technical experience and the market position that we hold makes us a good collaboration partner for our suppliers as they're exploring the new technologies in polymerization. So we work with our suppliers by taking samples of their new polymers into our labs, mix them into reference formulations we've established, and testing critical material properties. If you can go to the next slide, Brett. So mechanical properties, plasma resistance for semicon sealing, chemical resistance or rapid gas decompression performance for energy and chemical processing applications or types of tests we'll run. These evaluations have led in several cases to adjustments in the chemistry and or process that's being used in the polymerization. With each supplier taking a different technology approach, we see differences in the resultant polymers that they produce. Now, I've spoken about polymers and reference compounds, so let me just take a second to explain that a polymer is just one component of the compound recipe. The compound will consist of a polymer and a cross-linking agent, also known as a curative. So this cross-linker is what allows the compound to have elastomeric or rubber-like properties rather than, being rigid like a thermoset plastic. We might also add fillers to enhance specific properties for the applications we're formulating for. But this recipe of ingredients is what we're referring to as the compound formulation. Okay, so we have established reference formulations for different applications across different industries that help us evaluate and isolate the polymer's effect on the processability of the compound. Then once we've mixed the compound, we mold parts, we finish them, we post-cure them, and now we're ready to test them. We test the compounds comprehensively to characterize its performance. So physical properties, compression set, and sticking force are common tests that we'll run for all of our testing protocols, but other tests will be specific to an industry. So an example would be a formulation for semicon will be tested in fluorine and oxygen plasma resistance, while a compound for upstream energy might include high temperature amine resistance or rapid gas decompression testing. Our advanced technology group uses their formulation expertise to adjust the compound recipes and the process conditions to overcome deficiencies in the properties we might see when we use the new raw materials. So ultimately, our ATG team's defining how these raw materials can be used to make high performance compounds, or where the supplier can target new polymer attributes to help in that regard.